Okay, Assalamualaikum and good day. Today I will explain my statistical analysis on the relationship between the age of the school bus and their maintenance cost in the Lincoln-West school district. The main purpose of this study is to see whether older bus require higher maintenance cost, which is important for budgeting, maintenance planning and decision on bus replacement. For this analysis, I use data from the Lincoln School District data set. The independent variable is the age of the year bus, measured in year, while the dependent variable is the maintenance cost. I use simple linear regression and analyze the data using IBM expressed as statistic. The significant level used in this study is 0.05, which is commonly applied in statistical testing. First, we need to highlight a maintenance cost and age, and we find a scatter diagram, and we take a simple scatter, and we put a maintenance cost in y-axis and the age in x-axis. Okay, so I construct a scatter diagram with bus age on horizontal axis and maintenance cost on the vertical axis. From the scatter plot, we can see upward trend which show a positive relationship between two variables. This means the age of the bus increase, the maintenance cost also increase. The data points are fairly close to each other, suggesting that the relationship is moderately strong. For B, we find a regression and we take a linear. So we put maintenance cost independent and age independent. So we get a next. I develop regression equation to quantify the relationship. The regression equation obtained 337.30 plus 603.16x. Here represent the estimate maintenance cost and x represent the age of the bus year. The slope value of 603.16 means that for every additional year, the maintenance cost increase by about 303.16 units on average. Next, because to estimate maintenance cost of a 10-year-old bus, we substitute x equal 10 into the equation, because the question 6.4 asks we to equal 10-year-old bus. The estimate cost appropriately, we can get 6,369. This show how to regression equation can be used in equation and in planning. So next, we need to find a maintenance cost for C and age for. So we can get a question for C. Why we use one sample statistic? Because the question asks regression is greater than 0, so we need use one tail. So first, the null hypothesis state the slope slope is less than or equal to 0, and has one state the slope is greater than 0. Using a t-test 0.05 significant level to calculate t value is 8.844 and the p value is less than 0.05. Since the p value is very small, we reject the null hypothesis. Therefore, is sufficient statistical evidence to conclude that the age of the bus has significant positive effect on maintenance costs.